We're taking our candid, behind-the-scenes look at the data science hiring process up another notch. In this session, we're exploring several anonymized, real data science interviews with former Quora data science manager, William Chen. We will thoroughly cover what went well and what did not. He'll also explain methods for breaking down interview problems, how to best approach solving them, and strategies on communicating your thought process to the interviewer. As a reminder, we are answering your questions live via the YouTube live chat and via Slack, so you can ask your questions there and we'll bring them up at the end of the session. William, we'll hand it over to you for you to give us the inside scoop.
All right, thanks, Addison, for the intro. As Addison mentioned, I'm going to be talking about data science interviews. Some of you might know me as a data scientist or data science manager at Quora. I've actually recently left Quora. The reason is my wife and I are moving to New York City, so I'm presenting to you guys from New York City right now. It's 1 p.m. over here. I know those of you on the West Coast, it's still kind of early in the morning, but thanks for joining. Cool. This is an outline of my talk today. I'm going to start with my 4 general tips for doing well on data science interviews. I'm going to cover some common interview types and tips for kind of breaking them down. And then I'm going to cover some mock interviews and give some of my commentary on what went well in those interviews and what didn't go as well. So I'll start off with my general tips. Okay, so my first general tip is to actually always start with the simple. A lot of how data science is marketed and a lot of how data science is taught in school is actually somewhat too kind of like complicated or like not feasible to implement in industry. One of the common stories is that the winner of the Netflix prize back in like 2009 ended up having an ensemble of like hundreds of different models, but Netflix had a blog post that said they're not going to implement all 100 models. It's way too infeasible. That was one of the reasons. There's also a lot of things where like I see candidates talk about kind of like complex methods, but a lot of times just like smartly chosen simple methods can do much better, especially in terms of kind of ROI and total impact. For example, is sometimes if you just find a few well-chosen predictors and put it into something as simple as a logistic regression, or linear regression, it can vastly outperform a complicated model with a basket of generic predictors. So I always recommend people starting with simple solutions and mentioning you're doing so for feasibility. Feasibility is very important in industry. And a lot of times people in industry cite the Pareto principle, which says that 20% of the effort goes 80% of the way. And especially in industry, when a lot of things about like practicality and pragmatism are important, it's really always important to start with the simple solutions first and then potentially go deeper as a follow-up. This is actually very relevant for Kaggle because the models that end up winning Kaggle competitions are like very good and like very complicated, and they're usually ensembles of many, many models. But the honest thing is like these are usually too complicated to implement in actual production. Although some of the smartest ideas from the models definitely can make it into production, but not the full on thing. So my second general tip is to think quantitatively. As a data scientist, you should always try to think about things in a quantitative lens about how you can use data to prove something or make it better. You can make hypotheses and make assertions, but always be prepared to justify it with data. For example, you can talk about how a certain feature could hurt the user experience or things like that, but you should always feel free. You should always make sure to basically justify your assertion with data. So when you say hurt the user experience, make sure to come prepared with ways to measure that, like counting negative user actions or reduced retention or things like that. My third general tip, focus on the why. For a lot of the open-ended problem-solving questions, always start with why solving the problem is important. For example, for churn prediction questions, these are questions that look at why customers are stopping using the service or what makes customers continue using the service. I have some listed example whys here. One reason why kind of like retention and churn prevention is important is because it's always kind of cheaper and easier to keep users on your platform rather than acquire new ones. And if the company is able to proactively identify which users are likely to churn or stop using the service or cancel their subscription, These are great candidates for potential like promotional campaigns, or if they're kind of like big ticket customers, even like live reach outs from people on the sales team to help retain the users. In addition, for kind of like marketplace or network products, keeping users on the product is very important for like all other sides of the market. Like for example, if you need to have lots of drivers on some sort of ride sharing platform in order to make the rider experience better, or maybe in kind of like a home sharing platform, you need to have lots of options for guests to be able to stay in. And also, when finishing your answer, make sure to loop back to confirm that your approaches and your suggestions kind of like help focus and help solve on the why. My fourth general tip is to lead the discussion. A lot of this is kind of like having some sort of like structure or organization, and kind of like proactively kind of like identifying follow-up questions. So some sample frameworks that I'm going to kind of like talk through today. One is always to kind of start and end with the why. Like, why is this important? How does your approach help with the why? Make sure to signposts your sections, which means that when you switch from a section to section, you can say, now I'm going to talk about the next section. And then that makes it very clear to when you transition. Another thing is starting with the simple first, then go deeper. This is one of the tips from earlier. If you can anticipate and address potential follow-up questions, that's extremely valuable. That's when you can kind of like lead the discussion and kind of drive the interview yourself, and looks really good to interviewers. And at the end of the day, a lot of the important things in data science interviews is being able to communicate your approach effectively and kind of like construct an appropriate and valid data narrative to help kind of get to the solution that's needed. Cool. So now for these sections, I'm going to talk about 5 types of common data science interviews and some kind of like approaches or tips or things like that to kind of to do well at them. So the first one I'm going to talk about is the take home. This can be known as the take home test or the take home challenge or other things like that. These are written assignments that are given before an on-site interview or before a phone interview. They can vary for anything from some sort of like short auto-graded coding or SQL assessment on on any one of the kind of like online coding platforms, or a human-graded report that you have to spend multiple hours on, that if you get invited to the on-site, you might be asked to present it to a small group of people. For a lot of the human-graded reports, the structure is usually pretty similar. You're always provided with a few data sets, and you're provided with a series of questions that are meant to kind of like explore an idea and see what insights you're able to gather from the data set. So some thoughts about the take home. So what I've seen is that these are becoming more and more common, partially because the ability to dive deeply into real data sets and generate real insights is an absolute critical part of like what the data science role is and what it does. These are actually also time efficient for the interviewer to grade. They're usually graded in batches. Grading one take-home challenge takes less time than conducting a phone interview. And the grading is usually done by one of the data scientists on the team who are following a rubric. Since it's following a rubric, make sure you always answer all the questions, justify your approaches, and like communicate everything well. And also, I do understand that like these are definitely viewed as homework, and a lot of candidates don't like these. But I personally think that they can be fun. Like I think these are some of the most fun parts of the data science interview process. And I think it's much better to be able to do these like at home rather than doing the equivalent thing like on site under time pressure with someone watching you. And I think these are some of the good ways to like represent and like show off some of your strengths. So I have some tips for take-home challenges. Try to block off an uninterrupted period of focus time to finish the challenge. Like especially weekends, like these are actually like best done in one sitting, so you can kind of like be able to focus and like get into doing the challenge. Always do sanity checks of the data. So the data provided is usually either real data or meant to simulate real data, which means that it usually has issues that might affect analysis. So some things you can do are plot distributions, looking for outliers, checking for nulls and nans, just viewing a sample of the rows, counting unique values, finding common values, anything like that. I know Python has like a describe function that does some of this for you. The Kaggle dataset viewer is actually one of the most more impressive ways that I've seen like this done. Like if you put any dataset there, it will actually automatically do some of these sanity checks for you, which is really nice. And always like mentioning back to one of the general tips I mentioned earlier, try to tie it back to the main point, especially for the take-home challenges. You're working on something that's meant to try to make the product better. So you want to kind of like start with that, why is it important, and then at the end, like just summarize like why is your analysis and how is your analysis trying to achieve that goal. Okay, so for the next, I'm going to talk about SQL. So first off, I know that some of you might be surprised that like SQL is part of the data science interview process, but SQL is actually can be common in analytics focused data science interviews. Like even for non-analytics focused data science interviews, like SQL is the main tool and main language that data scientists use to be able to pull data from all of the kinds of data services like MySQL, Spark, Redshift, BigQuery. Data scientists use these to answer simple questions. Data scientists use these to get the data that they need to build their models and all sorts of things like that. So knowledge of SQL like is critical to succeed at certain data science interviews. So the structure usually looks the same. The interviewer gives you a SQL schema, so kind of description of the table, and a question, and you have to write out a query that can answer the question. They're usually a series of SQL questions, and they get a little bit progressively harder. The interviewer is looking for kind of like definitely a correct solution, but also wants to see and understand your comfort and translating a question into a correct SQL solution. So some of my thoughts here. Again, if you're being asked SQL questions in your interview, your data science position is probably very solidly in the product analytics or the business analytics space. So this is the part where you partner with cross-functional partners in order to make sure that kind of like business objectives or like product development objectives are like being met. Another thought is I personally think that the SQL interview is kind of like the most narrowly scoped data science interview because there's the space of potential questions that they can ask is actually much smaller than the space of potential questions in other types of interviews. So I think that this should become the easiest interview to prepare for if you kind of like know what you can expect. So I have some general tips here. I've looked through some of the SQL preparation resources. Like I think the SQL Zoo tutorials and Select Star SQL are the best ways to kind of like get ramped up and get acquainted with all sorts of things in SQL. There are a bunch of also like helpful SQL exercises on LeetCode, HackerRank, and SQL Zoo that are helpful. And all of these platforms, my favorite part is that you can just do them on your browser without having to install anything, and that just makes it so much easier. Another tip is try to utilize with clauses, also known as subqueries or CTEs. Like this makes your organization a lot better, and it makes it better for you to make sure that you have a pulse on like the pace and like where you're going in a SQL question, and also is great for the interviewer to kind of follow along. Also, there are common kind of like SQL question patterns that with enough practice on the resources that are recommended, you should be able to recognize pretty quickly. Some things is recognizing what parts of the question directly translate to where clauses, recognize when you need group bys immediately, recognize joins and self joins specifically. And some advanced questions might even require a window function. And an additional tip I have is also try to look at how SQL is kind of formatted. Like SQL uses SQL with tabs, just like making sure that certain areas are tabs makes the SQL look nicer, makes it easier to follow, and also kind of a signal to your interviewer that you're like familiar with the space of writing SQL. So in general, like, I think if there are any interviews in data science that are the easiest to prepare for, like my personal take is the SQL interview is the easiest. Cool. Now I'm going to talk about a more open-ended interview loop. So the product metrics. So the metrics. So the interview for product metrics usually looks like something like this. For a given feature, like what does success look like? And the specific thing they're looking for is something that's like quantifiable. Like this is the role of a data scientist, especially any data scientist that does things in the product analytics space. So the interviewer is looking for something that's focusing on as like easily quantifiable, very precise metrics that the team can use to track their goals for the quarter or the year or something like that. So this is a very big part of the product analytics kind of flavor of data science role. In product analytics, you'll work closely with product managers, engineers, and designers to make sure that feature launches are actually helping the team reach their goals. Cool. So I have some tips here. There for any sort of two-sided marketplace, always make sure that you have metrics for the supply side, the demand side, and the marketplace as a whole. Like there's actually a lot of there's a lot of companies that can be represented as two-sided marketplaces. Of course, you have the ride sharing companies, the home sharing companies, the e-commerce companies, even the social network companies. So we have people that both create user-generated content and people who kind of read or consume user-generated content. So a lot of different companies are kind of in the two-sided marketplace part, and always make sure that you have metrics for both sides and also something that connects them as a whole. And this ties back to my tip about thinking simple first. A lot of the metrics that you propose are the ones that you would need, that data scientist industry would need to be able to communicate with a broader audience of people beyond data scientists. So this is communicating with like product managers and like cross-functional representatives. Like counts of things are usually the best kind of place to start if appropriate, and you can dig in deeper to see, you can dig in deeper if necessary to go into more complex metrics if appropriate. So these interviews don't necessarily have like correct answers, but the important thing is really to kind of like justify why you're choosing such metrics or success criteria. For example, like one big thing that's important kind of user-facing metrics is, does your metric bias towards power users? Like, is it okay that you're biasing towards power users? Do you want to represent the people who contribute most of the actions on your product, or do you want to kind of like represent the general base on your product? So a lot of the things in the product metrics space, like there are actually sets of common metrics that I think that if you get familiar with, these will actually make the interviews much easier, and let you kind of avoid some of the more complicated metrics that are not as feasible. So some common metrics like daily active users is a humongously like is a humongous is a very common metric in any sort of like user application, and also making sure that the daily active users come back the next day. One very common metric is action counts, just like counts of desirable things that happens. This can be anything really that listed, like clicks, sends, interactions, signups, all sorts of things like that. Like these are all like very common, very simple metrics that teams can work to optimize. Going a little bit more complicated, you do have ratio metrics. So these are usually ratios of some sort of like with some sort of action count on the numerator and something else on the denominator. You can have things like click-through rate. If you have some sort of like recommendation system or ads or things like that, you can look at efficiency, like look at how well things are utilized, how well the supply is utilized, how long it takes for something on your platform to get sold, or things like that. Also, you have metrics. You can have metrics around revenue. You can also have metrics around time spent, like time spent watching a video, listening to something, time spent on a page or an app or on the product or things like that. Also, if you're interviewing, like try to, if possible, if you can make an account on the product for the company you're working for, explore and play around with as many features of the product as you can, especially the features that it seems like they're actively developing. And then kind of like preparing like a list of metrics you think a company might care about. Like these are things that you can kind of like try to dig in and play around with all of the features and like try to see what's up before the interview starts. Okay, so I have links to more resources. I know it's hard to click on these links from a live stream, but for the common metrics, if you Google A16Z metrics, these are blog posts from a venture capital firm, Andreessen Horowitz. They have very good series on basically like common metrics, common generic metrics that startups use to kind of like measure how well they're doing. There's also a bunch of metrics in the kind of the growth space. Andrew Chen has lots of good essays on the space. Pinterest has shared like all of the metrics on their growth dashboard, so you can go and see what metrics they're tracking as well. Also, congratulations on Pinterest for IPOing today. I saw they, yeah, it's not that relevant, but cool day for them. Cool. So next, I'm going to talk about the metrics investigation interview. So the metrics investigation interview, it also usually has a standard format. It usually is something like your team notices that an important metric has dropped by a certain amount. How would you figure out what has happened? So these interview questions are common because these are actually common scenarios for a lot of data scientists in the analytics space. Like someone, usually a product manager or a data scientist, notices a surprising change in a dashboard, and a data scientist or a team of data scientists has to investigate and seeing what's going on in the ecosystem. Are there things that are breaking? Are there kind of like weaknesses in the system that we should kind of address to make sure that we can keep metrics up and make sure that things are growing in the way that the company wants to. So for a lot of metrics investigations interviews, like there's a common framework that you can use that covers most of the things that could potentially happen. Like this is a framework that you can use to kind of organize your thoughts and make sure you're being comprehensive. Like although to really do well at these types of interview questions, like there are specific things that the interviewer try to kind of like lead or push you towards that might be something that is fairly is fairly common in the sorry is fairly common for something that the team has to focus on. So so the first thing is internal factors. So data issues are always a possibility. Any launches you do, bugs, experiments you run. There are also external factors, which I think is some of the most interesting ones, like especially seasonality. Like most products have some sort of weekly seasonality. There also might be kind of a yearly seasonality. There might be special holidays, especially holidays in countries that are like are not in the country that you're most familiar with, like whatever your competitors are doing in the space. You can also look at aggregations. Like a lot of times, data scientists can look at metrics through various kinds of aggregations, like looking at country or looking at things like device, looking at time of day, cohort, campaigns, attribution source, and things like that. Like these actually like give you a lot of good insight information to try to isolate a specific cause. You can also look into doing a funnel analysis. Like, is there something that's happening upstream that's impacting your metric downstream? So, for example, if what you're looking for is something like actions taken on the platform, you can see whether app opens are affected or something like traffic is affected as well. And like these things like happen because these things happen sequentially. Like anything that happens upstream might impact your metric downstream. Cool. So for tips on how to prepare, it's actually pretty. I was actually really happy when I found this resource. It's actually really hard usually without this resource for people to be able to kind of like explore and prepare on like how to prepare for a metrics investigation exercise. But Google Analytics actually has a demo account where they let you access real data from the Google merchandise store. If you Google like Google Analytics demo account, you'll find this link. And there's actually some fun data you can look at. If you get familiar with the dashboard, you can look at are more users visiting on weekdays or weekends? Which device is most responsible for the weekly seasonality patterns, and why? Do you think there's a certain device that's more common on a specific day of the week? You can look at things like, are there certain countries that have a very high conversion rate? Are there certain countries that basically have a very disproportionate amount of the sales and revenue on the site? And also, like, you can try to dig into, like, this is a literal metrics investigation. Like, is there a certain split that explains most of the daily upward spike on February 7th, 2019? Cool. So next, I'm going to cover experimentation. So experimentation is a common topic for kind of product analytics interviews where where the company does large-scale experimentation on users. And you might, these are also the part of the interview where you might be asked to explain statistical concepts and terms like t-tests, confidence intervals, p-values, or how long to run an experiment. So a lot of times, like you'll be asked to set up an experiment. Like setting up an experiment is important because experiments are really the golden standard for determining causality. Like if you want to understand if your feature is actually resulting in real impact, like experimentation is the way to go if you can do it. So I kind of have a 3-step process to setting up an experiment. The first one is always, again, starting with the why. Like, why are we doing this experiment? Like, are we doing this experiment to grow our user base? Are we doing this experiment to kind of like improve our recommendation algorithms or things like that? Like starting off with the why is like so important to kind of motivate the experiment, create hypotheses, and also lead to like the next set of metrics, to lead to a set of metrics you might want to choose. The second part is choosing a set of metrics that you want to use for experimentation. So this is actually very relevant to the product metrics slides that I presented earlier. A lot of the metrics actually go somewhere in here. Like they're also for metrics, like these can usually be broken down into three different sets of metrics. The first one is success metrics. Like what are the metrics that define success for your feature or your product? These are the metrics that you want to increase. These are the metrics that you want to grow because this is the whole purpose. This is why we're doing the experiment. There's also counter metrics. So these are the metrics that you don't want to hurt. Like if you're increasing one thing, you don't want to create some sort of trade-offs for something. You don't want to create trade-offs for something else. Like this is where you put this is where you put the metrics that you don't want to hurt. There's also just a general set of monitoring metrics or metrics that are a good practice to monitor for most of your experiments, like things like speed or revenue, or any other metrics that you're not sure where they're going, or metrics that are not measurable in one of your groups. For example, if you're launching a brand new feature, like you definitely do want to monitor usage of that feature, but there's no way that metric is available in your control group because your control group doesn't have that feature at all. The third part to set up is choosing your test. So some choices are a standard A/B test on a certain percentage of users. Like maybe the control is like 10% of users and the experimental group is 10% of users. The size of the percentage is chosen based on power analysis, which is the usual way of determining how long you should run, like how long you should run an experiment or how many people you should put in your various buckets. There are also some other experiments that are kind of somewhat popular or used in the space. Like these are country randomized A/B tests. Like these are used when you have certain kind of network effects, where you want basically everyone in a certain kind of like small local network to experience the same treatment or control. You can also have something like a long-term holdout A/B test. These are used in the presence of other kinds of network effects, or to kind of like just see how things are going in the long term. So I have a link to more resources here. Some of my favorite resources here are written by kind of like Ron Kohavi. He's the head of experimentation at Microsoft. He has a website, explatform.com. He also has a bunch of Quora answers. These give a lot of insight into kind of like practical concerns or practical things in A/B testing. And a lot of kind of like the questions about A/B testing are kind of like covered by the general by the general materials that he might share. If you want to learn more about statistics, Open Intro to Statistics is a good primer. It's a pay what you want book, and there's a chapter there that actually explains power analysis, which I think is very valuable. Like power analysis is how you figure out how long you should run your experiment or how many buckets you should attribute to your experiment or something like that. If you want to learn more about network effects, the Lift engineering blog has a series of blog posts about network experiments in the presence of network effects. And I think it's a good primer to kind of like understand some of the complexities of experimentations when you have these kind of network effects where people in the groups might affect each other. Cool. So now I'm going to kind of like quickly go over some other interviews that you might encounter through data science interviews. So I have three right here. The first one is programming. There's some data science interviews that will involve a programming loop. These usually just are meant to test your comfort with coding. Whether this exists or how strong it is kind of depends on how much of the data science role you're interviewing for is similar to a software engineering role. There's actually a bunch of resources to prepare for programming interviews, but I like the standard kind of like LeetCode or HackerRank, where you're able to kind of like practice problems on the internet. Another one is predictive modeling. I'm a fan of Kaggle. Kaggle is a great resource here, especially the getting started in the playground competitions, and especially the ones that use categorical and numerical data. Like these are actually excellent to kind of like get familiar with predictive modeling, get familiar with like overfitting, get familiar with a lot of the key parts in predictive modeling, especially feature selection, which is very important. The discussion forums for a lot of the learning competitions is very helpful to just see like what other people have done. Again, especially like I think feature selection and creation is like very valuable and things that people share openly on a discussion forums for a lot of the kind of entry level competitions. Some other interviews might test things like data intuition. Like these interviews evaluate if you understand kind of complexities of working on real life messy data sets. These are things that are harder to prepare for, but these are things where kind of like past projects or things that you've done can really help here. Cool. Okay, so as promised, I'm going to go through some mock interviews with commentary. These are three different attendees of the Kaggle CareerCon, and they're being asked generic data science interview questions by a volunteer from Kaggle. The audio files are a little bit modified to protect anonymity, but these are hopefully ways to kind of like these are hopefully ways to kind of like I'm happy to give commentary and then let's see what happens. Cool. So the first mock interview, I'm going to talk about product. Okay, the first mock interview is kind of the intro point to a product metrics interview. So the question here is like, can you name a feature of an internet product that you enjoy? How would you improve this feature? So I'm going to play a recording from a CareerCon participant.
I would like to talk about the thing that I use very often, Google Map. I think one particular feature of Google Map I've been found quite useful, but I think there is still room for improvement. And this is the feature where after you set a destination, where you would like to go on that day, you can actually search for example, restaurants or gas stations along the way. So the Google Map actually plans for the most efficient route for you. I personally found this feature very useful, especially when I'm taking road trips to some new places. But I keep wondering whether the team could take this feature up a notch and actually because Google is such a very well-rounded platform, people search for anything related to their life almost on the platform. And I'd imagine they have a lot of information about the individual, for example, their preferences for just the type of activities they would like to do, the type of restaurants that they like to stay at very often, or the type of hotels, like these kind of questions. So I keep wondering whether Google Map can get hold of this information, of course, with the person's permission, and automatically suggest points of interest along the way, rather than just showing, say, gas stations when the people request for it.
Okay, cool. So in summary, the person here really likes the feature in Google Maps where when you're navigation to somewhere, you can do a feature something like search for stops, and you can find gas stations or restaurants or other things on the way. I like this feature a lot personally, so it's actually really cool seeing someone else who likes it as much as me. One of my favorite parts about this is Candid shows kind of like genuine interest and excitement about a specific feature and has enough general knowledge about Google Maps and its feature to suggest a somewhat reasonable improvement here. The improvement they're suggesting right here, well, it's a potential improvement, is kind of like adding some sort of um, adding some sort of explore stops feature in navigation. So Google, you can wait for Google Maps to kind of recommend you places that you might want to stop by when you're going somewhere. One thing that the answer could improve is that this candidate could uh, add a lot more about the reason why this feature would be a positive. Like the candidate was able to kind of like talk about that this would be a cool feature to have, that Google has capability within privacy concerns to make this feature happen. But any sort of like real kind of like product justification should be important. Like I'm not speaking for Google or anything, but it could be like, I'm not employed by Google. I can't speak for Google, but it could be possible that Google Maps is trying to increase usage of kind of like its business pages. So some sort of feature like that could be just like making sure that people can people use business pages more, or people use the explore features more, because I know that's also a feature in Google Maps. There's a part 2 to this question. Okay, so the part 2 of the question, what metrics would you use to verify that your improvement, explore stops and maps navigation, is successful? This is the same interviewee.
Okay, metrics. So I think we're talking about a recommendation system or a recommender system here. So it will be an automatic system based online, where it automatically suggests something that you think that the software thinks the customer is going to be interested in or rate highly about, right? So one metric to see whether these suggestions are correct or effective would be to gather some time series data. So for example, I could train my machine learning model in, say, the month of the spring of 2018, and then keep collecting data in the following month and test my my model's effectiveness using that newly collected data in the second month to see, okay, did this person give any more ratings on these sites that Google recommended to him or her, or the similar sites, and see whether those ratings correlate highly, for example, with the ratings that the algorithm predicted.
Okay. So one thing I want to comment on is this candidate focused a lot on model metrics instead of product metrics. Like these are both important kinds of metrics, but if I were the interviewer, like this would be a very natural point to kind of like try to push the interviewee to mention more about product metrics. First, I can comment on the model metrics that the candidate suggested. The candidate suggests using the model to predict ratings of places on Google Maps. Ratings is not as good here because ratings on Google Maps are like sparser than other actions that might be useful. Like when you navigate to things, it's like definitely not certain that you're going to end up doing a rating of it. It seems like this candidate might be pattern matching a little bit too much to connect recommendation systems with ratings. Like this is popular among kind of like school exercises and popularized by the Netflix prize. But something more appropriate and relevant and less sparse here would be something like added as stop. If Google can propose a certain item, Google can actually see whether or not someone added it as a stop. If they added it as a stop, it's a successful recommendation. If they didn't add it as a stop, it was not successful or maybe not viewed recommendation at all. Like that would be a lot less sparse and a lot more potentially viable here. Also, the candidate suggested waiting a month to collect data to validate their model. like that. That's useful. That's useful after you launch your model. But while you're making the model the first time, you can always use the standard like train, test, validation data sets to always kind of see how your model is doing. So that's the commentary on the model metric parts. The next follow-up question I would ask here is definitely around kind of product metrics. Like these are the things that kind of like a question like this is really trying to get at. Like we have to figure out why we're adding this feature in the first place. Maybe the purpose of this feature is to have people kind of like visit Google Maps local business pages more often. If so, the success metrics here would be kind of like views or impressions on local Google Maps pages. Some counter metrics here is that you don't want the addition of the Explore Stops feature to kind of like distract people or like take away from the general navigation process. So the counter metric could be something like total amounts of trips completed or something like that. And also you could also have various, you could also have other kind of like just like general metrics as well. The general metrics could be stops added, or other things like speed, or things like that. Again, like I don't. These are my guesses for the good answers to these, but I don't have the actual knowledge of like what would be the thing closest to what Google Maps is doing here. This question right here also segues really well into an experimentation question as well. So then setting up the experiment, this could be a standard A/B test because there wouldn't be as many any network effects here. Cool. And move on to another question. This is a churn prediction question. This can sometimes make it way into the take home, but it's kind of a predictive modeling question that is also not an uncommon take home question as well. So the question is, choose a subscription service. Your team is responsible for making a model to predict which users will cancel their subscription. Can you walk me through how you would build that model, including features, model choice, and model evaluation? So this, again, is a standard data take-home kind of challenge.
Okay, so subscription service, something like Spotify Premium, then, for example. With a subscription service, oftentimes you can get figures such as number of hours the user's been using it, their patterns of usage. For example, are they listening to the same song over and over again? Are they using our custom playlists? Are they listening to your radio services? Are they following only specific artists? And over time, we can get a pretty comprehensive image of that individual user's personalized tastes. To determine if they're going to potentially stop using your service, if we can notice a trend in, for example, sudden decreases in usage for extended periods of time, or if we made some update on our end to our services, for example, if we're no longer collaborating with certain artists like Taylor Swift back in, I think, 2016, if our service stops deciding to feature that said artist that this user really liked listening to, then it's pretty likely that that user will stop using our service because what they came for is no longer being offered. But generally, the main metric that would be, I think, is worth looking into is just number of hours, because it's the most reliable measure of user engagement with our service.
So that was the full answer that the candidate provided. And like this would be exactly the point where the interviewer comes and kind of like asks for the next steps, like with that feature, like what would you go on to do? So some of the things about this interview, this candidate seems to be mostly brainstorming. So brainstorming is good to do in just in normal circumstances, but it's kind of dangerous to do just general brainstorming without too much of a framework. The candidate could have benefited from slowing down and kind of like just going through the parts of the interview, like step by step, and also just like focusing on the simpler things first. Like I agree with the candidate that like hours on the subscription service, or basically time spent listening to music, is a fantastic predictor. Like you could start off with just saying we're going to make a model, maybe a logistic regression with just one feature to make the simplest version of the model, and then we're going to validate it through the normal kind of like cross validation and things like that. Like that already is a fantastic place to start, and then you can kind of offer to go into more complicated things. But the candidate here kind of like got stuck in kind of a brainstorming way, and like could benefit from kind of like leading the interview, like going through all the steps and kind of like starting off simple instead of kind of like going through lots of different things. Okay, this is the last one. So this is more of a technical question in predictive modeling, things that are kind of very familiar if you do Kaggle competitions. It's about overfitting. What is overfitting? How do you tell if you're overfitting? How can you prevent overfitting?
I'm sorry, I'm just writing down the three because I always get lost whenever I try to answer. Okay, so overfitting is a technique that no, it's not a technique, I'm sorry. It's an error that we can encounter in the models that we train. That means usually in our data, there's always some type of noise that is unrelated to the real patterns of our data. And overfitting means that we make our model fit to that noise so that it will perform well just with the specific data set that we have, but it won't be able to generalize to other data sets. So that's overfitting. How could I tell if I'm overfitting? Well, usually a good indication of that you are overfitting is testing your model, like separating your data set in training and testing data, or validation data. And if you have that your accuracy in your training data is higher than the accuracy in the testing or validation data, then it's a pretty good indication that your model is overfitting because it's not able to capture the general patterns in your data, but it's mostly just basing all of the predictions on the training set. So when it comes to the testing set, it's not able to identify correctly because it's a new set that it has never seen. So that would be the difference between like memorizing and learning, for instance. How can you prevent overfitting? Well, there are some techniques because you always try to have that bias versus variance balance in your models. So the first one is just using regularization. Regularization is a technique that actually tries to overcome overfitting, and that is really useful to kind of denoise the data or try to adapt your coefficients to just ignore more of the unhelpful data in your model. That's one. There's always also a good idea to try to have your training set to be very representative of the data that your population has, a good representation of your population, and so that when you train your model and it is performing well, it is able to capture all of the distribution that you have in your regional population. Overfitting can be also, there are always some hyperparameters in the models. I mean, every model has different hyperparameters, and you can always tweak those to avoid overfitting. For instance, in deep learning, there are actually so many of those. But yeah, that's pretty much it, I think.
Cool. Okay, so I thought the candidate gave a solid answer to all three of these. Like the answers don't have to. The answers like the answers don't have to be perfect. Like, but the answers, like, I think it was very solid. Like the candidate showed that they were generally familiar with all of the things involved in the general things around overfitting and seem to have done some of the things in practice. Like, this is right for more follow-up questions that the interviewer may ask. My favorite part of this interview was kind of the structure and the signposting and organization. Like this is a 3-part question, and a candidate had like paper and pencil prepared Like this is something that I think most people should have prepared for a phone interview, like paper and pencil to like kind of write notes, especially in a phone interview where sometimes like communication is a little bit more difficult. Like write notes on what you plan to cover. And then once you go through all three of the sections, like signpost, like say that, just say, okay, how do I tell if I'm overfitting? Then go into your section. Or how do I prevent it? Like go into that section as well. Like the signposting is very helpful on like organization on your side to make sure you cover everything, and also really helpful for the interviewer to kind of like also follow like all the parts as well. Like this is great for phone interviews. It's great for public speaking. I think it's just a great thing to do. Cool. Okay. That's all the things I have prepared. I'm happy to take any questions in any time that's remaining.
Hey, William, thanks so much for that. I know we've been seeing a lot of comments come up all throughout Slack and in our YouTube live chat saying how valuable the session's really been. They really love all the slides that you've been putting together. So thank you so much for your time. We are getting towards the end of our time, so we're going to save all of our questions for Slack.
Mm-hmm.
Those of you asking questions in YouTube Live or in Slack, William has told us that he'll be sticking around for just a little bit after this presentation, answering some of those questions in the Slack channel. So we have a Slack channel dedicated specifically to this session, so be sure to log in and ask your questions there. But William, that is all the time that we have. Thank you so much for your help. We definitely know this is one of the most popular sessions we've had of the past 3 days, and so we're super thankful for your valuable insight.
Awesome. Thanks, Addison. Yeah, I need to make a Slack account, but I'll see you guys in Slack. I'll try to stick around for a few hours to try to answer as many questions as I can.
Excellent. Thank you so much.
Cool.
For the rest of you who are watching, we'll be back here at the top of the hour with a panel from a number of individuals who have switched careers over into data science. So please be sure to check that out, and we'll see you guys back in just a little bit. Thanks.